Research continues, of course, even when no immediate benefit is expected. At the University of Technology in Graz, Austria, young scientists are seeking to discover why water placed in 2 glasses and subjected to a high voltage charge will climb the sides of the glasses to meet. It doesn't do it at some random part of the glasses, but at exactly the spot where the water from the 2 glasses will meet. If one moves the glasses away from each other, the water creates a hanging bridge that can be up to 2 centimeters long. So far, even the world's greatest scientists have been unable to explain the phenomenon. So far, there is not even a theory about the sensational behavior of the water.
An exact microscopic theory and an exact understanding of what is happening here, we haven't found that yet. And that is the reason that we're continuing to work on it. It's what makes this all so interesting. We would expect electrolysis, but under no circumstances would we expect a stable bridge that acts the way we see it acting here. That's what makes this all so fascinating. A half hour later, the bridge fatigues and collapses. Through the use of a red and a blue color filter, the movement of the bridge becomes more visible. It is the apparent flickering that amazes the scientists. From a physical point of view, it should not be taking place in this form because water cannot be compressed. Here we're using the same kind of measuring technique that we use in mechanical engineering, anytime that we're dealing with very high speeds in a machine, whether it's rotational speed or flow velocity. It requires a special measurement technology, which we're using here on the water bridge.
One can see that blue is trying to get to the red side and red to the blue side. The next step in examining the phenomenon more closely is the use of a thermal imaging camera. With its help, we can see more clearly the mysterious processes taking place within the bridge. It is not difficult to see that all hell's let loose here.
The problem with such measurements is always that every measurement poses new questions instead of providing new answers. That means that we are constantly observing dynamic effects, and they raise questions that we cannot answer. So we have to consider new measurement processes that would allow us to find out, for example, where the structures that we observe in this water bridge come from.
For the layman, it looks as though water could breathe. But for the scientist, it continues to be an unexplained phenomenon for now.